Welcome back, students. In this video, we're going to look at radical polymerization. Polymers are really big molecules. And when I say really big molecules, I mean unimaginably large. What happens when you make a polymer is you take what's called monomer. So a monomer is a single unit, whereas a polymer is a many unit chain. So you take a monomer and you allow it to react with sometimes itself or maybe other molecules over and over and over again until you form this long chain. And when we discuss polymers, we usually see them in what's called a repeating unit or a repeat unit. So here is an example of a monomer. This is styrene. And when styrene reacts to form polystyrene, which is styrofoam, what happens is the pi bond ends up creating a new sigma bond to connect the molecules to one another. So I've just highlighted the new sigma bond in blue, and the rest of the structure, that is a styrene monomer right here. So they are repeating over and over and over again to form what we call the repeat unit. If we wanted to look at just one section of the polymer, the simplest section, that if we narrowed it down to just those atoms, we could essentially make a stamp out of those atoms and just repeat, repeat, repeat and get the entire polymer, that's what a repeat unit is. So I'm going to put parentheses around an example of what a repeat unit would look like. So I'm going to put parentheses around here, and what you'll see is a letter N in the lower right-hand corner, and that means repeat this some number of times to form the polymer. When people are starting to explain polymers to you, because they're so big, they don't really have an end point that we draw on a sheet of paper. They have an end point in real life, but on the sheet of paper it would be unrealistic to draw its end point, and that's what these squiggly lines are meant to illustrate, is that this just continues in both directions over and over and over again. Let's talk about how these polymers are made. One way is through radical polymerization. In the radical polymerization, we're going to look at a mechanism, but there's 3 steps to that mechanism. The first part is initiation. In the initiation step, you form the first radical from your radical initiator, and you carry out the first addition step to your monomer. Next comes propagation. This is where most of the reaction is happening, right? After you have formed that initial radical and done the first addition, then that compound, that radical, just keeps reacting with monomer over and over and over again until you start to run out. Then the final step is called termination, and this is where 2 radicals are going to come together and react, and then the result is no radicals at the end. There are 2 modes of termination. One is a coupling mode where 2 single radicals come together, and then you get an extra long chain because the ends of your chain have come together. And then there's another way called disproportionation, which is where there's a hydrogen abstraction involved at the end of all of this. I'm not going to show you that one because only certain polymers terminate that way. Let's first look at initiation. For initiation, you need a radical initiator to begin with. Peroxides are really good ones because they are cheap and they are easily accessible. You can hit a peroxide with light or heat, and what ends up happening is this bond breaks and you get 2 peroxide radicals. And that is the first half of your initiation step. This part might seem weird, but within the world of polymerization, you have the radical form, and then you do the first addition to the first monomer. And those 2 pieces together are what we call initiation within the realm of polymerization. So now I'm going to have this happen. Notice how here I have 1, 2, 3 carbons and 1, 2, 3 carbons. I purposefully made sure that I put my radical on the carbon that I labeled number 2 because that carbon happens to be secondary. If I would have put the radical on carbon number 1, which I will highlight in yellow, then I would have had a primary radical, and that's not as stable and it's not going to form. So you have to be careful about where you're putting that radical. So these two pieces together are your initiation step in polymerization. Now let's look at what propagation looks like. Once you've formed that initial radical and done that first monomer addition, now propagation is the addition of more monomers. I changed my monomer here. Notice how on the first slide it was styrene and now it's propylene. And I'm going to continue this process where we're adding carbon to my chain. So I'm going to do some highlighting here, right? This was from the first monomer, and so was this. This is from my second monomer. The thing that links the two is the new sigma bond here, right? I'm just trying to draw on top of the blue bond. I don't want to make it look like a double bond, so I'm going to erase it and redraw the whole thing in green. And the propagation step just continues over and over and over and over again. It's the step that takes most of the time in polymerization. So you just keep going through propagation and your chain continues to lengthen. Now, long chains are actually really important in polymer chemistry because your properties of your polymers are dependent upon the chain length. So if your chains are short, you're going to have different physical properties than if your chains are long. And at some point it levels out, but you need to get to that point where your chains are long enough that the properties stay consistent. Because imagine you're a plastics company and you are making water bottles and you sell this water bottle, but the chains weren't long enough. And so when your consumer puts tap water, room temperature tap water in it, well, that was too hot for that water bottle and it collapsed, right? You're going to have a pretty unhappy consumer. So you need that consistency. And again, this just happens over and over and over and over again until the termination step, which is what we're going to look at next. This is one way to show termination. This is called coupling. In termination, your two radical chains find each other. And they find each other and they react so that they form a new bond. I'm going to go ahead and continue my color coding and my product so I can show you where these two chains combine. So first, I'm going to draw this part, and then I'm going to connect my two chains with a green bond to say that this bond is new. It's not part of the carbons that were drawn on the left-hand side. And now this is the rest of my chain. In this termination process, notice how this part where we drew that new green bond has a different pattern than the rest of it. And that pattern leads to a situation where that bond is pretty easy to break in comparison. And so if we heat our polymer in order to try to reform it into something new, that bond can break pretty easily. And that's where recycling comes into play. Have you ever noticed that on the bottoms of your bottles, there's these numbers? And it doesn't have to be water bottles. It can be anything that is packaged in your kitchen. You know, it could be bottles of lotion. It can be ketchup bottles. It can be the containers that your grapes and strawberries come in. It can be the bag that your grapes come in. All of these are made with plastics, and plastics are just a class of polymers. Now, a lot of times people will think, hey, these must all be recyclable, and that's not really true. Recycling is trickier than you think it is, because that bond that we highlighted on the previous page, when you end up trying to take a recycled material and reform it into something new and usable, that bond is really easy to break. And when we heat the polymer in order to create a situation where we can put it through an extruder and reform a new bottle, you end up degrading part of the polymer. And that's an issue because the polymer's properties are based upon molecular weight. And so if you're degrading the polymer, you're chopping it into smaller bits, so the molecular weight decreases, and then you don't have a consistent molecular weight. So really, even though there's these recycling numbers on the bottoms of your containers, only 2 of them are really able to be recycled well. Polyethylene terephthalate, which is recycling number 1, and high density polyethylene, which is recycling number 2. These are called high value plastics. The rest of these, if your city collects them, I would guess that there aren't actually recycling them anymore because there's just no market in it. So if you are a conscientious person and you would like to try to do your bit to save the planet, try to purchase things that are made with plastics that are polyethylene terephthalate or high density polyethylene, or better yet, no plastic, or if you can afford it, things that are in glass. Glass is always recyclable, but these plastics really struggle in the recycling process. Let's wrap up. In this video, we talked about polymers, we defined what a polymer was, and we looked at the radical polymerization process. We looked at some common polymers, we saw the repeating unit for polystyrene, and then we made polypropylene while we were going through that polymerization mechanism. We saw that recycling numbers are a thing and you should look for them on your containers because only recycling number 1 and 2 are actually successfully recyclable. Thanks so much for watching. This is Katoni signing out.